Speciation has been a key theme throughout the history of our planet. Old species die out and new ones grow to fill the environmental niches left behind. So how did a small, rodent-like creature evolve into arguably one of the most important animals in the development of civilization itself, the horse? It all has to do with environmental changes in form and function. Hi, I'm Lexi Olson, class of 2025, and this is Equine Evolution, form and function in response to environmental change. Let's start with the Eocene horse. Following the KT extinction at the end of the Cretaceous period, the mammals that had lived in the shadows of dinosaurs for millions of years were relatively small creatures that survived day to day by scurrying through thick vegetation. This early ancestor of the horse dwelled in forests and was no larger than a fox. It had 4 toes in the front and 3 toes in the back. It even featured toe pads used to grip the ground instead of supporting weight. As small prey animals, their main defense was their flight response. They were very quick at running away. The animal's teeth were suitable for eating shrubs, branches, and leaves, which are relatively soft vegetation compared to the grasses that later horses would eat. As a whole, this scurrying creature remained relatively constant due to little environmental change. As the environment began to change, so did the animals. This next animal, Mesohippus, was still a forest browser, but it was twice the size of its Eocene counterpart. Plate tectonics on the North American continent were beginning to form the Rocky Mountains, which would have unexpected impacts on these early horses. The growing mountains would create rain shadows, areas of significantly decreased rainfall behind mountainous regions that would greatly change the available vegetation. The environment of North America was slowly transitioning into eastern grasslands instead of the lush forests that the Eocene horse was used to. Mesohippus still had teeth unsuitable for grazing, but it was developing more complex premolars and upper incisors. In addition to its longer legs, the 4th toe of Mesohippus had become vestigial, now having only 3 toes on each foot. Our evolutionary journey continues with Merychippus, featuring the most prominent changes in horse form and function. While we can all agree on what we see and observe in these fossils, we must often use inference, information not directly available to our senses. Observation alone would not reveal the causes of these drastic changes in anatomy. However, we can infer exactly what kind of environmental changes caused the animal's tooth structure and longer legs using knowledge of our geologic past. Due to the lack of rain on the leeward side of the mountains, much of North America was becoming grasslands. Therefore, it was advantageous to have longer legs to travel farther and faster through the plains, as well as finding more food. One important observation is that the radius and the ulna in the forearm of Merychippus became fused into one bone. This eliminated rotation about the forearm and only allowed for a forward and back motion. The sacrifice of the leg's flexibility allowed these horses to rapidly outdistance their predators, using their legs solely for locomotion and kicking without any other wasted motion. In addition, the 2 side toes on Merychippus became raised up off the ground as the center toe became stronger and was able to support more weight. However, these changes would not be enough to help Merychippus adjust to its new environment. There were also prominent changes in the animal's teeth. The transition from browsing teeth to grazing teeth was influenced by the fact that grass is tougher than most plants. The teeth became ever-growing, so they would never succumb to wear. Enamel ridges added a protective covering as well as an increased crown height. The lower jaw chewing also changed from an up and down crushing motion to a side-by-side grinding motion, which was more suitable for digesting tough plants compared to soft plants. Even modern horses use this side-by-side chewing today. By the Pleistocene era, about 100,000 years ago, North American horses stood on a single hoofed toe. The previous 2 toes had become splits paralleling the center toe. While its early ancestors relied on scurrying and hiding, the Pleistocene horse had traded its agility for full running power. Modern-day horses have still maintained a very similar form and function, and have not changed much since their contact with humans and domestication, implying the evolutionary success of the horse's anatomy and its adaptation to its environment. Horses went extinct in North America about 10,000 years ago due to changing food sources and climate. However, a small population was able to cross the land bridge to Eurasia, giving rise to various breeds. When the Spanish conquistadors returned horses to the Americas in the 1500s, they at last reunited the modern-day horse with its ancestral homeland.
Although these prehistoric horses developed their specific forms through natural selection, the various modern breeds today have obtained their differences through artificial selection and human selective breeding. While shaped by drastically different causes, the fundamental process and principle of form and function have remained constant.